Okay. Good evening, Sri Mukhopadhyay, and welcome to the YourPedia. So we are starting the full mock. So first of all, just give you a brief intro about yourself.
Okay, my name is Sridhar Mukhopadhyay. I'm a resident of New Delhi. I have completed my bachelor's in chemical engineering from University School of Chemical Technology, Guru Gobind Singh Indraprastha University. And right now, I'm preparing for my PSU interviews.
So now you just want to give an entry for which exam?
Actually, right now I'm preparing for different PSUs, but BARC and ISRO are the target points.
So now you have just got the call from the BARC and ISRO.
No, I haven't got. I'm preparing for next year. For the next year, I'm preparing.
So have you completed your B.Tech?
Yes, my B.Tech is completed.
In which year?
2021.
So now this year also BARC also calls us. So you didn't apply this?
No, this year I did not apply. I'll be applying next year.
Okay. So recently also there is a one examination also came from the BARC.
Okay.
You just apply, then you can just apply by the 23rd of the May.
Okay.
This is also for the scientific post.
Okay.
So what's your favorite subject?
Favorite subjects are CRE, heat transfer, fluid mechanics.
Fluid mechanics. Okay. So let's talk about the fluid mechanics. What do you mean by capillary?
A capillary is a small tube through which a liquid rises by virtue of and it is held in position by virtue of the surface tension, the forces of adhesion between the fluid and the material of the capillary.
That okay, so capillary is always meaning the fluid is going to be rise. Am I correct?
No, it can fall also in the capillary in case the angle of contact is obtuse, more than 90 degrees. The angle of contact between the fluid and the material, if it happens to be greater than 90 degrees, then there will be a fall in the level
so
of the
it's depend upon the angle of contact,
yes, yes.
Not the other things.
It depends. Basically, it depends on whether the adhesive forces are more or the cohesive forces are more. If the cohesive forces are more, then the angle of contact will be negative, and there will be a fall in the
negative.
The angle of contact will be obtuse, and there will be a fall in the capillary.
Okay. So in the case of mercury, it is meniscus should be the. I know about the meniscus also. What's the meniscus look like?
Meniscus will look like in the case of when adhesive forces dominate over cohesive forces, the meniscus will look like a concave meniscus, and in case cohesive forces are dominant, then it will look like a convex meniscus.
You know about there is a one needle that is having the higher density than water, but still just stand on the water level. How?
Needle.
Yeah, needle.
So I know that the needle usually sinks in water
after some time.
Okay.
But for some instances, it can be still in the water and can float. Just let us take another example. How the mosquito can sit on the water level.
A mosquito can sit on the water level like when its weight is balanced by the buoyancy forces.
But it's not be true, no? In that case.
Yes. In case if it sinks, then the buoyancy force will be not equal.
I will just give you the hint. What is the surface tension?
Sir, surface tension. Okay. Surface tension is surface tension of water. Surface tension of water. Then the mosquito basically makes use of surface tension to stick onto the surface of water. Yes, that's how it stays.
Acha. Okay, can you just give me an example of a laminar flow?
Laminar flow, in the case of a circular pipe, whenever we keep the velocity low enough so that the Reynolds number stays.
Any practical example? That's a theoretical example. Na? If we just take the velocity lower, it is a laminar. If velocity is higher, it is a turbulent. Any practical example?
Practical example of laminar flow is okay. In a river, when the velocity of water is very slow, then we can regard it as laminar flow.
Is this possible ki in a river velocity is slow?
No. No, it is not possible.
I know about the rotational or irrotational flow.
Yes, sir. Yes, sir.
What is that?
Yes, sir. Rotational flow is when the particles of fluid, the fluid elements, they rotate about their own axis. And when they do not rotate about their own axis, it is known as irrotational flow. How we recognize rotational and irrotationality in a fluid flow field is that we take the curl of the flow field and the curl of the velocity field. The curl of the velocity field, if it is zero, then it is the flow is irrotational, and if it is non-zero, the flow is rotational.
Okay, so how the streamline in the case of rotation and irrotational flow? Are you know?
Streamlines. In the case of irrotational flow
And rotational flow.
Streamline flow. In the case of ideal fluid, streamlines. They. Okay, fine. In the case of rotational flow. In the case of irrotational flow, basically streamlines are defined by stream functions. So we'll make use of stream functions for this purpose. So for in a two-dimensional flow, the x velocity Vx will be del phi by del y, and Vy.
Can you just tell me in the rotation irrotational flow, streamline will exist or not?
Yes, sir. I'm just calculating that. Then Vx by del y minus del. Fine. Sir, like if the flow is irrotational, then the streamline will exist only if it follows the Laplacian equation. Then the streamline will exist. Otherwise, what is mandatory if the flow is irrotational? That is, if the flow is irrotational, definitely there will be a potential flow field. Potential function will exist.
So maybe it may be exist or not, right?
Yes, sir. Yes, sir. Streamlines may exist or may not exist.
Okay. Can you just give me any example of a irrotational flow and a steady flow?
Irrotational and steady.
Not practical one, any example which you know about.
Okay. Sir, the flows to which Bernoulli's theorem can be applied.
So give me any example.
Like for example, sir, we take the flow through a pipe, and it is crossing, say, a Venturi meter, through which we can measure discharge also. So we can apply the Bernoulli's theorem, and the fact that we can apply Bernoulli's theorem means that those assumptions of irrotationality and steady flow, it is valid for that particular system.
I know about the meta center.
Yes, sir, meta center.
What is the meta center actually?
So meta center is the point of intersection of the line that is passing through the center of gravity of the body and the line of action of force, the line that is passing through the point of the line of action, the intersection of the line passing through the center of gravity and the center of buoyancy. Yes, sir. The line of intersection through the line. Basically, it is the intersection of the two lines, one which is passing through the center of gravity and one which is passing through the center of buoyancy.
Okay. Just tell me this, take two ships. One is a cargo ships, which is just used to transfer the, just like a, matlab aapka saman le aane ke just like a, and there is a one passenger ship.
Okay, sir.
Okay. So in which case you just keep the metacentric height higher and lower? And what is the way to do this?
Okay, so metacenter, basically, if the metacenter is above the CG, then it will top.
But in both cases, metacenter should be above the CG because it should be stable. Right?
Yes, sir.
I'm just talking about the metacentric height. In which case you just keep the greater height, in which case you will just not need to the keep the greater height.
Greater height. Cargo ship and passenger ship. In the case of cargo ships are basically heavier than passenger ships. So in that case, the CG will be lower. So, sir, the metacenter height should be higher for the case of cargo ships.
Why?
No, sir, I'd like to change my answer. The cargo ship, the metacenter height will be more in the case of passenger ships, because metacentric height.
I don't know about the rolling or pitching.
No, sir.
Okay. Titil Mukhopadhyay, I will just give you the feedback about from my side. Overall, you are a good. Little bit I feel that you have a very high confidence about the things. So one thing I will suggest you. This is not the negative one, but sometimes what will happen when we just speak in a very fast manner, so we are not recognize actually what we want to say. So take some time, है ना? थोड़ा सा बस स्लो करना है अपने को.
Okay, sir.
है ना? उससे क्या होगा कि आपको माइंड को सोचने का टाइम मिल जाता है कई बार नई चीजों पे. कई बार क्या होता है कि हमारी ये फ्लुएंसी अगर नहीं बनती है जो आपकी है एक्चुअल में, तो फिर कॉन्फिडेंस डाउन जाने लगता है. अगर आपको नहीं पता कोई आंसर, लेकिन अगर आप थोड़ा सा सोच के आराम से बोल रहे हो ना, दैट विल गिव अस सम टाइम्स टू यू कि कोई आंसर इधर उधर का अगर आ रहा है तो आप उसे जल्दी कवर अप कर लोगे. बाकी यू हैव अ गुड कॉन्फिडेंस, योर वे ऑफ स्पीकिंग इज आल्सो गुड, योर आंसर इज आल्सो क्लियर, है ना?
Yes, sir. Thank you, sir.
Okay, thank you so much.
Thank you, sir.
Now the another faculty will interact with you. Over to you, sir. Nikhil sir. Nikhil sir, am I audible? I think he will join again. शायद there is some issue. आप 21 के बाद क्या कर रहे हो फिर बेटा?
मैं अभी M.Tech pursue कर रही हूँ currently.
M.Tech from where?
IIT Kanpur.
Good. Which branch?
Chemical engineering.
Chemical engineering. तो अभी आपका लास्ट ईयर है?
जी.
2 साल में हो गया वहाँ पर कि अभी टाइम लगेगा?
नहीं हो जाएगा, अभी हो जाएगा.
I am also just doing the biomaterial lab project from the IIT Kanpur. In a Kantesh Balani sir, I know about it.
No,
Kantesh
sir.
Balani, Shekhar sir.
No, sir.
That is belongs to the mechanical department, material science.
Okay, sir.
Okay. Okay, over to you, sir. Nikhil sir, if am I audible?
Okay, sir.
Okay, thank you.
Hello, Titir.
Hello, sir.
My first question to you: what is the difference between forced convection and natural convection?
Forced convection takes place when the fluid is brought into motion by an external source, like a pump or a motor, etc. Whereas in natural convection, the transfer of heat takes place by adverse density gradients. That is, like the fluid always moves from a region, like wherever there is a lower density, there will be higher temperature, and that is how the natural convection currents will be set up due to adverse density gradients.
Okay. So each convection caused by wind is a forced convection or a natural convection?
Yes, sir. Can you repeat the question?
The convection caused by wind.
Yes, sir. Wind. So convection caused by wind is it should be forced convection, sir.
Okay. How?
So it should, because wind, basically whenever wind flows from one region to another region, it is due to pressure gradient that happens. So the pressure gradient basically causes the wind to flow from one region to another region. That is the driving force behind the movement of the wind. So, and that is what carries the energy along with it. So that is how it can be deemed to be a forced convection.
Okay.
Yes, sir.
What is external convection and internal convection?
External convection and internal convection. Sir, not sure about the answer.
Okay. Okay, tell me for which case, either natural convection or forced convection, the heat transfer coefficient will be higher?
So heat transfer coefficient should be higher for a forced convection. This is because in the case of forced convection, the velocities are of much larger scale. The fluid velocities are of much larger scale, and like on the scale of natural convection, a large density gradient will be required to like generate that much amount of velocity as we can generate very easily with the case of forced convection. So since the velocity is higher, fluid velocity is higher in case of the forced convection, hence the heat transfer coefficient will be higher in the case of forced convection.
Okay. So what is the physical significance of Nusselt number?
So the physical significance of Nusselt number is that it tells us about the rate of heat transfer by convection through a medium to the rate of heat transfer by conduction through the same medium of the same thickness. So that is what is the ratio, the two ratios which Nusselt number measures, the ratio
Okay.
between the two quantities.
So what happens when Nusselt number is equals to 1?
When Nusselt number is equals to 1, that means, sir, that the rate of heat transfer by convection is comparable to the heat transfer by conduction. Both are equal.
Okay. What is the difference between heat transfer coefficient and thermal conductivity?
So heat transfer coefficient is basically a phenomenological coefficient. Firstly, heat transfer coefficient H is basically based on the fact that the film which is very close to the phase boundary, that is like almost stagnant, which is not actually the case. First, and then secondly, its existence comes from the Newton's law of cooling. And another important fact is that H is not a material property. H is a property of both the material and the phase boundary. And whereas in the case of thermal conductivity, it is a proper material property, which is either dependent or independent of temperature.
Okay. Okay, now tell me, what are the different factors that influence selection of a distillation column internals?
Can you repeat the question, sir?
What are the different factors that influence the selection of distillation column internals?
Distillation column internals, sir, firstly, it is affected by the pressure drop inside the distillation column. That is, we should choose our internals accordingly so as to create a pressure drop like optimum enough, so as to cause the fluid and vapor flow inside the distillation column. And apart from that, and then, sir, the internals such as downcomer, etc., they are dependent on like the flow velocity and how much molar flow rate do we require in our distillation column. That basically decides the area of how much area the downcomer should occupy.
Okay. Anything else?
No, sir.
Okay. Okay, what are the difference between the extraction process and the distillation process?
The extraction process is a process in which a solute is extracted from a solid or a liquid by another solvent. That is referred to as extraction. Distillation is where we extract the more volatile components into the vapor phase and the lesser volatile components are thrown into the liquid phase. So this is the basic difference between distillation process and extraction process. And extraction process does not make use of relative volatility difference, whereas distillation process makes use of relative volatility difference between its components in order to separate them effectively.
Okay. Anything else?
And distillation, extraction. The partition coefficient is described differently in the case of we have a partition coefficient that is described in the case of a liquid extraction process, whereas if the partition coefficient is high, like in the case of distillation column, what we do is we decide on the basis of relative volatility which one is more volatile and which one is lesser volatile, and we do our distillation process accordingly. Whereas in the case of liquid extraction, there is a partition coefficient like YC by YA upon XC by XA, where Y and X are basically composition of the solute and carrier phases in the in the carrier phase and in the solute phase, in the solvent phase. So like that relation gives us the partition coefficient. So that partition coefficient, higher the partition coefficient, greater is the ease to separate the components, separate the solute from the carrier and bring it to the solvent. So these are the differences. Like there it is relative volatility, here it is partition coefficient. That describes that how much desired separation can be obtained.
Okay.
Yes, sir.
So what is selectivity?
So selectivity is yes, sir. So, selectivity is the ratio of beta. Beta is yes, yeah. Selectivity is the ratio of so the definition that I said for
The definition that you
Yes,
said
sir.
about the partition
Yes, sir.
coefficient, is that correct?
Yes, sir. No, it is for selectivity. I'm sorry, sir. That is for selectivity. That is for selectivity. Sir, selectivity is basically the ratio of the.
But then what is partition coefficient?
Partition coefficient. Sir, partition coefficient will be YC upon 1 minus YC upon XC.
1 minus YC?
No, sir. YC upon 1.
YC XC छोड़ो, बताइए क्या है वो? जिसको नोमेनक्लेचर नहीं पता होगा वो YC XC करके क्या करेंगे?
हाँ, basically the partition coefficient is basically the ratio of the amount or the amount of solute that has been that is in the solvent phase to that what is in the carrier phase.
Yeah, partition coefficient. Okay, okay. Okay, tell me, what are the situations where liquid extraction becomes more attractive over distillation process?
So when the relative volatility difference between the components is very low, there we prefer the liquid extraction over distillation, because distillation is energy intensive, and if the relative volatility.
ये एक पॉइंट हो गया, और बताइए.
ये एक पॉइंट है, और lower relative volatility difference and
अच्छा, एक्सट्रैक्टिव डिस्टिलेशन के बारे में सुने हैं?
हाँ सर, बट
अभी याद नहीं आ रहा. ठीक, कोई प्रॉब्लम नहीं है. अच्छा, लिक्विड एक्सट्रैक्शन में कुछ एप्लीकेशंस बताइए, कुछ एग्जांपल्स कुछ भी बताओ.
लिक्विड एक्सट्रैक्शन में कोई भी ऑर्गेनिक सोल्यूट होता है, ऑर्गेनिक सोल्यूट कोई भी सोल्यूट होता है जो कि एक ऑर्गेनिक सॉल्वेंट में प्रेजेंट होता है, तो उसे यूजिंग वाटर हम एक्सट्रैक्ट कर सकते हैं.
कोई सा भी ऑर्गेनिक को?
नहीं,
तब तो इजी हो जाता है बहुत.
हाँ,
सॉल्वेंट वाटर ही ले लेते हैं हमसे.
राइट. हाँ,
ठीक है, कोई बात नहीं. अब तो बीआरसी के लिए प्रिपेयर कर. न्यूक्लियर इंडस्ट्री में कहीं पर यूज होता है एक्सट्रैक्शन?
हाँ, कहाँ पे?
न्यूक्लियर इंडस्ट्री में कहीं पर यूज होता है?
न्यूक्लियर इंडस्ट्री में डिस्टिलेशन
ठीक है, कोई
नहीं
और?
सर, नहीं सर।
अच्छा, लास्ट क्वेश्चन पूछता हूँ आपसे। व्हाट आर द फैक्टर्स दैट अफेक्ट्स मास ट्रांसफर रेट्स इन एक्सट्रैक्शन?
Mass transfer rate and extraction. Mass transfer rate in the process of extraction is affected by mass transfer rate and extraction. सर फर्स्ट तो है कि like driving force, how far it is from the equilibrium, how far the concentration is from the equilibrium. That is the first point.
ठीक है,
First thing. Second thing, that eventually points to the partition coefficient of the system also. Higher the partition coefficient, greater is the rate of mass transfer.
ठीक है,
And okay. XC, XCY, क्या?
ठीक है, चलिए हम आपको फीडबैक दे देते हैं, है ना?
Yes, sir.
कन्वेक्शन, ठीक है। कन्वेक्शन caused by wind, तो ये फोर्स होगा या नेचुरल होगा, ये डिपेंड करेगा कि किसके फ्रेम ऑफ रेफरेंस में आप बात कर रहे हैं।
Okay,
अगर
sir.
आप अपनी बॉडीज के हिसाब से बात कर रहे हैं तो फोर्स्ड है, बट विथ रेफरेंस टू अर्थ आप बोल रहे हैं तो नेचुरल, ठीक है
Okay, okay, sir.
है ना? वहाँ अर्थ में तो डेंसिटी डिफरेंस से तो क्रिएट हुआ हुआ है ना?
हाँ, हाँ, हाँ.
तो इसलिए बस फोर्स बोलेंगे तो गलत होगा वो।
Okay.
फिर एक्सटर्नल और इंटरनल कन्वेक्शन क्या है, मतलब ठीक है, वो तो एक पाइप है, पाइप के अंदर में अगर फ्लो पंपिंग किया गया है तो वो आपका ये हो गया, इंटरनल कन्वेक्शन हो गया। और बाहर में अगर विंड उसके ऊपर में एयर फ्लो हो रहा है तो वो एक्सटर्नल कन्वेक्शन हो गया, ठीक है।
Okay.
मतलब साइमल्टेनियस इंटरनल और एक्सटर्नल भी हो सकता है इसका मतलब, ठीक है।
Right.
उसके बाद नसरल नंबर का सिग्निफिकेंस, तो नसरल नंबर जब वन होता है तो ऐसा कुछ कंपेरेबल नहीं है चीज, कंपेरेबल वो प्योरली कंडक्शन है। इफ नसरल नंबर इज इक्वल्स टू वन, देन इट इज प्योरली कंडक्शन, क्योंकि ये दोनों को ये रखता है कि अगर वन से ज्यादा ही होना चाहिए तभी नहीं तो नसरल नंबर की यूज ही नहीं है वहां पर, ठीक है।
अच्छा, ठीक है.
नसरल नंबर वन है, मतलब वो प्योरली कंडक्शन में है, वहां पर कुछ हो नहीं रहा है, कन्वेक्शन कुछ नहीं हो रहा है।
Fine, fine. Okay.
फिर आपका डिस्टिलेशन कलम इंटरनल्स का क्या क्या फैक्टर्स इन्फ्लुएंस करेगा, तो एक तो हम लोग जब डिजाइन करेंगे तो उससे पहले देखेंगे कि क्या मिनिमम टेम्परेचर क्या है और मैक्सिमम टेम्परेचर क्या है, ठीक है।
Okay.
फिर देखेंगे कि वो प्रोसेस फ्लूइड जो है, जो भी फीड है या प्रोडक्ट है उसमें, उसका फाउलिंग कैरेक्टरिस्टिक्स क्या है,
Okay.
ठीक है। फिर उसका और कितना रिएक्टिव है या कितना कोरोसिव है वो देखना पड़ेगा, ठीक है। जैसे H2S का प्रेजेंस होगा तो कोरोसिव नेचर का रहेगा।
हाँ.
फिर कितना कितना सेंसिटिव है वो टू कंटेमिनेशन। फिर जो आपने बताया जो भी आपका रिक्वायरमेंट डेल्टा पी, वो हाइड्रोडायनेमिक रिक्वायरमेंट्स को हम लोग कंसिडर करेंगे। तो ये सब रिक्वायरमेंट है जो हम लोग देखेंगे यहाँ पे, ठीक है। फिर एक्सट्रैक्शन और डिस्टिलेशन का डिफरेंस, तो एक तो आपका यही हो गया कि रिलेटिव वोलेटिलिटी हो गया और एक रिलेटिव सॉल्युबिलिटी हो गया, ठीक है। और यहाँ पर हम लोग एक सॉल्वेंट यूज कर रहे हैं, एक्स्ट्रा कंपोनेंट यूज कर रहे हैं, जहाँ की यहाँ पर करते नहीं है, एक थर्मल एनर्जी यूज करते हैं, ठीक है। सो ए न्यू इमिसिबल लिक्विड फेज इज क्रिएटेड बाय एडिशन ऑफ सॉल्वेंट to the original mixture, whereas in distillation a new phase is created by the addition of heat,
Right.
ठीक है।
Fine.
और जो एक्सट्रैक्शन करता है वो पूरा प्योर प्रोडक्ट नहीं देता है आपका, ठीक है, क्योंकि वो तो उसके बाद तो मिक्सचर ही रहता है, तो फिर फर्दर सेपरेशन प्रोसेस रिक्वायरमेंट है यहाँ, जहाँ जहाँ तक आपका डिस्टिलेशन में आप प्योर प्रोडक्ट्स अचीव कर सकते हैं, ठीक है। डिस्टिलेशन में फ्लेक्सिबिलिटी आपके पास कम रहता है ऑपरेटिंग कंडीशंस का, पर यहाँ पर आपके पास फ्लेक्सिबिलिटी ज्यादा रहता
अच्छा.
है। और कहाँ किन किन केस में ये एडवांटेजेस रहेगा एक्सट्रैक्शन, एक तो आपने बता दिया कि लो रिलेटिव वोलेटिलिटी है तो वहां पर होगा,
हाँ.
ठीक है। और ऐसे बहुत जगह है जहाँ पर अगर समझ लीजिए कि डिस्टिलेशन करना पड़ेगा, जहाँ पर प्रेशर रिक्वायरमेंट बहुत लो है ना, दैट इज अबाउट 50 mmHg, तो वहां पर हम लोग इतना इक्विपमेंट कॉस्ट या इतना ऑपरेशन कॉस्ट नहीं लगा के एक्सट्रैक्शन कर सकते हैं, वो एडवांटेजेस हो सकते हैं वहाँ। और एक्सट्रैक्टिव डिस्टिलेशन क्या होता है? एक्सट्रैक्टिव डिस्टिलेशन ये होता है कि डिस्टिलेशन हो रहा है प्लस एक्सट्रैक्शन भी हो रहा है वहीं पर। और ये कहाँ पर होगा? जब वो मिक्सचर एजोट्रोपिक होगा, क्योंकि उसका वोलेटिलिटी बहुत लो है, तो हम लोग ऐसा सॉल्वेंट डालेंगे जो कि वो एक दो मिक्सचर में ये सोल्यूबिलिटी करके फिर हम लोग का ये आपका सेपरेट कर सकते हैं विद फेज चेंज। ठीक है, फिर एक्सट्रैक्शन जितना भी आपका मास ट्रांसफर का यूनिट ऑपरेशन है जो भी है, ठीक है, तो सबका आपको एग्जांपल्स जानना होगा। मैंने आपको बताया था लग रहा पहले भी, तो एग्जांपल्स आप देख लीजिए, जो भी इंडस्ट्रियल एप्लीकेशन है क्या क्या है, कहाँ कहाँ यूज होता है, क्योंकि बस जेनरिक बोलेंगे तो पता नहीं चलेगा, क्योंकि इंडस्ट्रियल एप्लीकेशंस बोलेंगे तो उससे बहुत सारा क्वेश्चन निकलेगा। ठीक है, व्हाट आर द फैक्टर्स दैट अफेक्ट्स द मास ट्रांसफर रेट्स इन एक्सट्रैक्शन? एक तो आपने बता दिया कि ड्राइविंग फोर्स जो है ना, उस पर डिपेंड करेगा। ठीक है, एक एक डिपेंड करेगा फेज कंपोजिशन में, एक डिपेंड करेगा टेम्परेचर में, फिर डिपेंड करेगा डिग्री एंड टाइप ऑफ एजिटेशन, एजिटेशन भी रिक्वायर है यहाँ पे। और जो फिजिकल प्रॉपर्टीज है, जो भी इंटरफेसियल टेंशन हो गया या डेंसिटी हो गया या विस्कोसिटी हो गया। ठीक है, ओके ओके सर, आई एम डन फ्रॉम माय साइड।